Now let's look at problem 15 on the review sheet. It says an ice cream company finds that at a price of $4, demand is 4,000 units. For every 25-cent decrease in price, demand increases by 200 units. Find the price and quantity sold that will maximize your revenue, right? And so they're giving us some information here. They're telling us demand, right? We know, or we talked about, we studied our demand function. Remember, our demand gives us how many the quantity of items that we can sell at a certain price, right? And so when they're telling us that we have a price of $4, our demand is 4,000 units. I'm just going to write a little chart here. You don't have to do this chart, but it may help you see things a little better, right? So I'm going to put the price of the ice cream, I guess. When it's $4, I know I have 4,000 units. I can sell 4,000 items, right? Every 25-cent decrease in price, so if I go to $3.75, my demand is going to increase by 200. So 200 more people are going to want to buy it, right? So that's going to be a 4,200. If I decrease that price again, yeah, that's not right, right? All right, I'm going to increase that demand or that quantity again by 200, which will be 4,400, right? And so what's happening here is every time I decrease the price by 25 cents, I increase my demand by 200. All right, and it happens for every 25-cent decrease. That means that there is a linear relationship between price and the quantity demanded, right? That means I can write a linear equation for that, right? Now, our goal in this problem is to maximize revenue, right? We have discussed over and over and over again that revenue equals price times quantity. And a lot of times I did revenue as a function of the quantity because normally we write our revenue based off of how many items we sell, all right? And so, I'm going to keep that in mind there, but it may not stay the same. What I'm going to do is I want to maximize this thing. I can't maximize this thing with these two variables here. I just need one variable. We won't look at doing the derivative when we have two variables. That's multivariate stuff, right? And so what we're going to do is we're going to try to write one of these variables in terms of the other, and then hopefully that'll help us find the maximum. The thing that's going to help us do that is to look at this linear relationship between price and quantity given by our demand function, right? Now, normally when we have a situation like this, we normally write our equations in terms of x and y, right? So we'll put our x here and our y here, right? Because the y depends on the x, right? The quantity depends on the price, right? And so when we have a linear relationship, we normally write it as y equals mx plus b. But in the context of this problem, the x is p and the y is q, right? So I'm going to write my linear relationship like this. We know m is the slope and b is the y-intercept. All right? So what I'm going to do first is I'm going to try to find the slope, right? That's the change in y over the change in x, the rise over the run, all right? I'm going to choose 2 points, right? This is like having 2 points. This is like saying that this is the point 4.004,000. And here the point 3.75, 4,200. And so if I want to find the slope, I subtract the y values. So I can do 4,200 minus 4,000. And then I'm going to divide that by the change in the x. So I subtract the x values. And what I'm going to do, once I simplify all that stuff together, I'm going to end up with negative 800. Okay? So I know my m is negative 800. Now I need to find out what b equals. Well, for me to find out what b equals, I need to plug in a value for q and a value for p, and I have a bunch of those values here, right? So I'm just going to choose the one that they gave me initially. Okay? So I'm going to plug in 4,000 for q. My m is 800, or negative 800. My p will be $4, or 4. And I'm trying to find b, right? I'm going to speed this up a little bit. Once you do all of this, you're going to find out that you're going to get a b equals 7,200, right? Negative 800 times 4 is 3200. Add it to both sides, I'll get 7200. All right, so my equation can be written as, with everything in it, Q equals negative 800p plus 7200. All right, and this is what I'm going to use to help me rewrite my revenue function in terms of one variable. All right, and so since this is solved for Q, I'm going to replace the Q specifically in here with negative 800p plus 7200. All right, and so I'm going to get R, I'm going to leave some space there, equals, I'm going to leave that P there because I'm replacing the Q and not the P. And so instead of writing Q here, I'm going to write negative 800p plus 7200. Now, normally here, we write this as a function of Q. Well, I only have the variable P in here. So this is actually R of P. Okay. I'm going to use my distributive property so I can simplify this because my goal is to find the maximum. I want to maximize it, right? So I'm going to end up doing a derivative. And this is actually a polynomial. And so having it in this form is easier to take the derivative. All right, so I'm going to take the derivative, R prime of P. I bring that 2 out front. I get negative 1600p plus 7200. All right. I need to set my derivative equal to 0 so I can find my critical points because that's where the location of my local min and local maximum values occur. It's not 1,000, it's 100. I subtract 7200 from both sides. Get negative 7200 on that side. Divide both sides by a negative 1600. And I'm going to get that P equals 4.5. Now what I can do is I can do an R prime line, plug in 4.5, and see if I get a maximum. All right, meaning my derivative is going to change from positive on the left-hand side to negative on the right-hand side. So I'm going to do that. I'm going to try a number like 0. I'll try a number like 1. So our price won't be $0. I'm going to try a number like 1. If I plug in 1 here for P in my derivative function here, same thing here, right? I plug in 1, I'm going to get a positive value. That means my function is increasing. And I plug in a number like, let's say 10. Well, that's going to be negative 16,000. That's definitely going to be negative. And so I'm definitely going to have a maximum. All right. So the price that maximizes my revenue is going to be $4.50. 4.5, $4.50. The quantity can be found by solving for Q in this equation that we created here. It's negative 800 times 4.5 plus 7,200. You put all that together, you're going to get 3,600 items. And it didn't ask us to find the maximum revenue. But we know revenue equals price times quantity. And if this is the price that maximizes revenue and this is the quantity that maximizes revenue, we can multiply those two together and that's going to give us our maximum revenue. All right? And that is that example. We're going to look at some other examples involving integration to definite integral in the next video.